No electrical metallic tubing or EMT cannot be strapped to ductwork. The National Electrical Code, or NEC, Section 358.30 dictates that EMT must be securely fastened in place and supported according to Sections 358.30b to f. This means there are specific requirements for how EMT should be supported, and strapping it to ductwork does not meet those requirements. NEC Section 358.30 code provides further detail stating that EMT must be supported and secured at intervals not exceeding 10 feet and within 3 feet of every outlet box, junction box, cabinet, or fitting. This ensures that the conduit is properly supported along its run and at termination points. Think of it this way: every 10 feet the EMT needs something to hold it up, and within 3 feet of any box or fitting it also needs to be secured. NEC Section 358.30c2 reinforces this, specifying that EMT must be securely fastened within 3 feet of every box, cabinet, or fitting where the EMT terminates. This prevents strain on the connections and maintains the integrity of the electrical system. The importance of this is to make sure that the wires within are not pulled at or have any strain at their connection points. NEC Section 358.30d clarifies acceptable support methods, stating that EMT must be supported from a messenger wire, structural member, or other approved means. Ductwork does not fall under the category of a messenger wire, structural member, or other approved means, making it an unsuitable support for EMT. So what is a messenger wire? A messenger wire is a supporting strand, typically steel, from which other cables or conduits are suspended. What is a structural member? Structural members refer to parts of a building's framework designed to support loads such as beams, columns, and walls. These are the types of things the NEC considers as approved means. The code emphasizes using reliable and structurally sound supports for electrical conduit systems. Using ductwork as a support could compromise the integrity of both the electrical and the ventilation systems. Firstly, ductwork is primarily designed for airflow and may not have the structural capacity to support the weight of EMT and its contents, especially over time. Secondly, attaching EMT to ductwork can create vibration and noise issues within the HVAC system, affecting its efficiency and performance. Thirdly, the NEC prioritizes dedicated support systems for electrical wiring to ensure safety and reliability. Improper support can lead to conduit sagging, wire damage, and potential electrical hazards. Fourthly, it's important to always consult the latest edition of the NEC and local building codes for specific requirements and interpretations related to EMT installation and support. Fifthly, ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local regulations. Their expertise is crucial for safe and compliant installations. Sixthly, when selecting support methods for EMT, consider factors such as the conduit size, the weight of the wiring, and the environmental conditions. Choose supports that are appropriate for the application and can withstand the anticipated loads. Seventhly, regularly inspect EMT installations for any signs of damage or improper support. Address any issues promptly to prevent potential electrical hazards. Eighthly, maintain clear communication between electrical contractors and HVAC technicians to avoid conflicts and ensure proper coordination of building systems. Ninthly, consider using specialized EMT support systems that are designed to minimize vibration and noise transmission. These systems can help maintain the integrity of both the electrical and HVAC systems. Tenthly, always prioritize safety when working with electrical systems. Follow proper procedures and use appropriate personal protective equipment to prevent injury. When installing EMT, consider using strut channels, clamps, and hangers specifically designed for conduit support. These provide a secure and reliable means of attaching EMT to structural members. Also, consider using cable ties, straps, or other approved fasteners to secure EMT to messenger wires or other support structures. Choose fasteners that are compatible with the conduit material and can withstand the environmental conditions. For outdoor EMT installations, use corrosion-resistant supports and fasteners to prevent deterioration and maintain the integrity of the system. Also, be aware of the weight limitations of different support methods. Consult manufacturer's data or engineering specifications to ensure that the selected supports can handle the anticipated loads. Furthermore, when supporting EMT from structural members, ensure that the supports are securely attached to the building's framework and can withstand the forces exerted by the conduit system. Be mindful of the spacing requirements for EMT supports as specified in the NEC. Proper spacing prevents sagging and ensures that the conduit remains securely fastened. Additionally, consider the potential for expansion and contraction of EMT due to temperature changes. Use expansion fittings or other approved methods to accommodate movement and prevent stress on the conduit system. Also, make sure to properly ground the EMT system according to the NEC requirements. Grounding provides a path for fault current and helps protect against electrical shock hazards. Think of it like a highway where electricity can flow safely back to its source in case of a problem. Also, label all EMT runs clearly to indicate the circuits they serve. This helps with future maintenance and troubleshooting. The labeling is like putting street names on those highways to know where they are going. Consider using color-coded EMT to further identify different circuits or systems. The color coding acts as a way to distinguish different electrical systems, similar to how different colored lines represent different subway routes. Remember, the NEC is not just a set of rules, it's a guide to ensure electrical safety and prevent hazards. Following the code helps protect people and property from electrical fires, shocks, and other dangers. So, always refer to the latest edition of the NEC and consult with qualified professionals to ensure compliance with all applicable requirements.